Hi everyone! In this video, we'll be taking a look at my new bat signal. The beam from this thing is awesome, and the design is extremely simple. This could be made using any flashlight as a power source, but in this case, I just so happen to be using the brightest flashlight available to the consumer market, the Imalent MS18. Just so we're clear, this flashlight was sent to me for free to use in this project at my request. If any compact light has a chance at projecting a bat signal all the way to the clouds, this is going to be it. This flashlight is unbelievably bright. You can't even hold your hand in front of it for long because of the heat. The output on the highest setting is 100,000 lumens. Let's see what that looks like in my shop. Just kidding. This is the 700 lumen setting. Let's turn it on for real. Wow! That sound you hear is the cooling fan kicking on inside of this flashlight, and it really needs it. The output from this thing is incredible, and so is the heat. This is an amazing flashlight. So let's take a look at what I have here. The core component of this bat signal, besides the Imalent MS18, is an optical quality Fresnel lens, 250 millimeters in diameter. I bought this one direct from China for about $23. What this lens allows me to do is take a normal wide-spreading source of light and focus it into a narrow beam, almost like a laser. This is called a collimated light source, where all of the light is traveling more or less in parallel. If you want to project an image, this is the kind of light that you need. Think of it like this pin board. Because the pins are parallel, you can push your hand into the back and get the same image projected on the other side. If these pins were bent or at random angles, the image would be lost. Now, if the light that comes out of a lens like this is collimated, the focal point on the other side will converge on a single point. If we place an object right at that focal point with a light behind it, the image of the object will be projected as a shadow in the collimated beam. Notice that the shadow is upside down. This happens because most of the object is not right in the middle of the infinitely small focal point, and when light enters a lens off-center, it exits at an angle to compensate, causing the image to cross over itself and flip. What this means for us is that the bat in our bat signal will need to be placed upside down. It also means that our projected beam is not actually perfectly collimated. Like everything in the real world, it's just an approximation that's close enough to get the job done. This is exactly the same functional setup as the desktop version we just looked at. I've simply increased the size of the lens and the light source and put the whole thing into this metal ventilation pipe as a housing. If you look down the barrel, you can see the Batman car emblem I've used to project the image, suspended in the middle of the tube on a piece of clear plastic sheet. Of course, I also had to surround it with an oval cutout to get the authentic look for this generation of the bat signal. My Fresnel lens fits perfectly in this 8 to 10 inch metal ventilation fitting, and I hold it in place with a few magnets. And then the power source, the 100,000 lumen Imalent MS18. I already know that this easily projects the bat signal several hundred yards, probably high enough for the side of any building. I don't have any good skyscrapers to test this on, but I do have far off trees, and if I get really lucky, maybe there'll be some clouds that come by. If the weather's right, they might only be half a mile off the ground, which always seems to be the case when the bat signal is used in Gotham, but more likely here in Michigan, they'll probably be 5 miles high and I won't stand a chance. We'll just have to see how lucky I get with the weather, and we'll see what happens. Well, we did not get lucky with the weather. There's not a cloud in the sky, and there's none even in the forecast for at least a week. Now, I've set up the bat signal here in a wide open field, so we at least have some very distant trees. These ones back here are about 250 feet distant, and over here is a group that is about twice that far. Now I'll start by testing this at about 1/3 maximum brightness. I think that will be plenty to see on camera, and we can go higher if we need to. All right, here goes, 250 feet beam distance. Is that not awesome? I could definitely get the image a little bit sharper maybe by adjusting the position of the bat inside this housing, but thanks to the optical quality lens, that is clearly a recognizable image. Let's move it over to the more distant tree line. The brightness does drop slightly, but remember, we are only at 1/3 power. We can still turn this up to the full 100,000 lumens. 500 feet away, and that is still extremely bright. We could easily multiply that distance several times over and easily recognize what we're looking at. I have to hand it to Imalent. This is an incredible flashlight to use with this project. Now, so far I have only showed this bat signal being broadcast onto trees, which obviously tree branches are not the ideal surface for a clean image. So I've moved the setup here to be in front of a large barn. So we have a big white flat surface that we can put this image on, and you can get a good idea of what kind of clarity we can get out of this optical quality Fresnel lens. So I'll start on the lowest power this flashlight goes to, which is 700 lumens, and then we'll go through the settings until we reach 100,000. Okay, starting at 700. There we go, 700, 2,000, 5,000, 10,000, 22, 30, 60, back to 700. So it cycles through all the settings up to 60, and then we enter turbo mode. There's 100,000 lumens right there. Pretty bright. Isn't that amazing that you can already see with such clarity at the lowest setting this flashlight delivers? Only 700 lumens. There are lots of little pocket-sized flashlights that can make an image that bright that you could use in a bat signal like this. $22,000 I think is just about right for the cameras. I might have to do a quick update video when I finally get some clouds to test this on. I hope you enjoyed this video. Let me know in the comments what you'd like to see me do next. I still read every comment, even on old videos. Thanks everyone who supports me on Patreon, and thank you for watching. I'll see you next time. Whew. I'm glad this flashlight has some auto heat sensors, because you have to be really careful not to actually melt the bat emblem on the inside of this housing. I might have just had that on a little too long. Hopefully I didn't wreck anything. See you guys.